Hi, guys. Heard you guys are having problems with the simulator, so I'm going to walk through what you would have seen if you were able to do it to help you understand the concept of planetary orbits and ellipses. So I'm going to start. It says we're going to click on Mercury. I'm going to click OK. Boom. Okay, there is Mercury. Now, the next thing it says, the semi-major axis is half of the major axis in astronomical units. AU is a standard unit of measure. It's the average distance between the Earth and the Sun. What would be the length of the major axis in Mercury's orbit? Now, if you remember, in the last lesson, the major axis was a line that went all the way across. I'm sitting here pointing at the screen, and you actually can't see me point. But can I do this? So I'll do this. Okay, so the major axis would be all the way across this space here. So the semi-major axis is the number you see right here of 0.387. So to get the full major axis, you just multiply that by 2, 0.387. I'm going to bring out my handy dandy phone, which is also doubles as my calculator today. So, calculator. There you go. 0.387 times 2. So that should give you a number of 0.744. Sorry, 0.774. That would be what you put in the first length of the major axis in astronomical units. Now, underneath that here is this number right here. That's 0.206. That's your eccentricity. That's how far away from an ellipse, from a circle, this elliptical orbit is. And again, you notice that the sun is over here, not center, and that's why it's an elliptical orbit. So now we're going to compare Mercury, Venus, Earth, and Mars. Now, I'm not going to go through step by step. You should be able to follow through as I bring these numbers up. If you have to stop, if you have to rewind, cool. That is what it is. I'll try to go at a pace that's somewhat usable. All right, so I'm going to switch to Venus. I'm going to click OK. There's Venus. Okay, now Earth. There are your numbers for Earth. And there are numbers for Mars. Okay. Oops, sorry. I never clicked OK. Let me go back to Earth. Click OK. There we go. There's our Earth. Notice the semi-major axis in astronomical units is 1. Okay. And then Mars. There's Mars. Okay. So there are your elliptical orbits. All right. So we're going to compare those. So you should be able to get a pattern of which is more circular by looking at it and by looking at the numbers. All right, part 2. We're going to show the empty focus, which is here, right there. I just clicked on show empty focus. Now I'm going to play with this little slider here, and I'm going to start at 0. Okay, notice where the empty focus is. Okay, I'm going to go to 0.1. 0.1. 0.2. 0.3. 0.4. 0.5. Approximately 0.6. And I go all the way here to 0.7. Okay, so that's going to help you with questions 2A, 2B, 2C. 2A, 2B, 2C. Okay, now the next one, place the planets in order from lowest eccentricity to the highest eccentricity. I'm going to give you a tip. I haven't gotten to this page yet in the reference table. I can do it up here. I can click through them all. That's fine. But if you turn to page 15 in the reference table, you'll see a page that says solar system data. Okay, and I'll actually bring that up here since we're doing this. Recording and background tab. Oops, can't do that. Boop. It's recording this tab. I'll stick there, I guess. If you go to page 15, you'll see a data table that has all of this information on it. But just for our argument's sake, since you don't have that in front of you, there is Mercury, Venus, Earth, Mars, Jupiter. Again, if you need to pause this, I'm just trying to not make this any longer than it has to be. You can pause it, look at it. Saturn, Uranus, Neptune. Oops, I went to Pluto. I went to Pluto again. Neptune. And, oops, getting crazy. There we go, there's Neptune. And then Pluto. All right, so there are the eccentricities. If you go to page 15 in the reference table, you'll see them listed down there. Okay, so there is a trick question for number 4. Just keep an eye on that. All right, so Kepler's second law, equal area law. Now, I'm going to go back to Mercury. Click on Mercury and click OK. So I'm back to this orbit. Now, I'm going to click the Kepler's second law. Now, I'm going to click and say start sweeping. Okay, click another one. Click that one. It's kind of fun. You can see if you can land in the same spot and so on. Oops. Oops. There we go. All right. So, my planet's sweeping around the sun. So as the planet's moving around the sun, click through. What's true of each of those wedges? We'll go back to your Kepler's second law. It should tell you what's true of each of those wedges. Okay. How does the length of the orbit change as it goes through those sections? What it means by that is this part of the orbit here versus this part of the orbit here or this part of the orbit here. How does the length of that section change? Okay. How does the length of that section change? All right. Now, just to have another look at it, I'm going to erase that. If I click this, you'll see the rainbow. Woohoo! Not really a rainbow, but a kaleidoscope kind of look, and looking down the light at the end of the tunnel, a little 3D kind of thing. But again, what's the difference between this here and this here? And what does that mean about how fast the planet's traveling in those situations and what the relationship of its velocity to the location nearest the sun? Okay. All right. Third law. Let me erase the sweeps here. Stop. Erase the sweeps. Okay. Pause animation. There's what I wanted. Okay. So Kepler's third law. So we're going to click the planet Saturn. Saturn. Click OK. All right. Now down below, we're going to add a few things. I'm going to click solar system orbits. Okay. Solar system planets. And we're going to label them. There we go. So you know which planet's which. All right. And now I'm going to click start animation. So I want you to look at those planets and come up with some answers that deal with Kepler's third law of planetary motion. It's a pretty straightforward one. All right. I hope that helps clarify the Kepler's law lab. Again, you may stop, start, rewind, whatever you need to do to help you with that. And hopefully that clears things up. I'll add one of these screencasts to every of these simulation labs just in case it won't come up on your computer. I do apologize. They're really cool simulations. I wish you could play with them a little bit if you can't. But best of luck, and until next time. And I keep staring myself in the corner of the screen. I might have to use that next time. Oh well. Have a good one.